Hi, I'm going to be talking about a collaborative design studio course I've been slowly evolving for the past several years that focuses on emerging technologies. I have a joint appointment at The Ohio State University that's split between our Department of Design and ACAD, a Computer Animation and Emerging Technologies Interdisciplinary Research Center, and also TDAI, a Data Analytics Institute. My background is in computer science, in graphics and AI, but I've been working with emerging technologies in arts and humanities contexts for the past few decades. Design education, like many other fields, has to wrestle with how to handle the flood of emerging technologies. The AIGA Designer 2025 report, among its many recommendations for design education, stressed the importance of adjusting curriculum to be able to adapt to changing technology. To this end, I've been attempting to give design students positive studio experiences using unfamiliar software and hardware in their design practice. I'll start with a quick bit of context, then describe the projects and content we cover, and then we'll finish with some evaluation of the typical challenges and successes I see. Our upper-level students are required to choose between 6 different collaborative studio sections, each having a different topic. This year's other studio topics include sustainable retail, healthy city, digital archive, material, and social design. These students are 3rd and 4th year undergraduates from our 3 different design majors: visual communication design, industrial design, and interior design. In nearly all of their design courses, they stick with their cohort within their disciplines. This studio is one of the few multidisciplinary collaborations they have. You can see some of my primary objectives for the course here. The class provides design students with opportunities to think about how and why they might encounter emerging technologies. Through making, they examine why some are more difficult or easy, and how they might consider issues like the usefulness or risks involved with unfamiliar new potential design tools. Each year, one broad topic is selected to provide the students with a bit of context to guide and bound their problem discovery. Next semester, we'll be considering the possible roles and impacts that emerging technologies may play in the future of design. In recent years, students applied their technology prototyping to the areas within the humanities and in data analytics research collaboration. The class begins with students emailing me responses to some questions about their current working habits, learning preferences, and group role tendencies. There are typically around 15 students in the class each year, and I assign them to groups of 3 or 4 students for the duration of the course. Students are divided into groups based on their major, school year, and self-described leadership tendencies in an effort to maximize group diversity. Most students have expressed positive feedback about this arrangement by the end of the course. So what do students actually do in this studio? They individually decide topics and technologies they would like to learn about. They then collaboratively negotiate the processes their groups will use for both design and decision making. They need to discover problems that combine their group members' interests and learning goals. And finally, they prototype design solutions in this emergent space. The course is divided into a 3-project structure that includes visualizing these possibility spaces, hands-on technology learning, and system prototyping. The students have about 1 month for each project. This first project lets students explore their potential research interests through very low pressure making. They individually choose 3 topics: an unfamiliar technology, an issue related to the annual studio theme, and 1 other personal topic of interest. As a group, they then must decide how to merge their group's large collection of topics into overlapping and intersecting areas of research. They're asked to use their favorite familiar tools for their making and to iteratively generate visual representations of the abstract possibility spaces created by their research topics. They investigate properties, problems, and projects existing within these spaces and discover connections they were previously unaware of. Outcomes range from concept maps and infographics to 3D renderings and animations, systems visualizations, physical models, and more metaphoric designs. The type of technologies students are curious about include things like e-textiles, AR and VR, machine learning and responsive environments, 3D printing, projection mapping, motion tracking, and virtual assistants. This past spring, some of the humanities topics that groups chose to study included cultural representations of death, music history, and cultural heritage preservation. There are a few specific challenges that frequently emerge for students in this first project. The first is understanding that the desired outcome is an abstract space of research possibilities and not a single design solution to one problem, as they're usually asked to produce. Also, it can be difficult to get some to trust that they will find overlaps between independent topics, but it's almost always surprisingly easy. Another significant challenge I have is the more I provide them with much requested examples, the more it shapes what they do. The fewer examples I give, the less they understand what I'm asking them for, and the more they worry about finding so-called correct answers. Students frequently inquire about the correct processes they should be using and are in turn asked to consider and evaluate their alternatives. It nearly always works out fine in the end, but many get stressed along the way, worrying about the lack of precise outcome constraints. For the second project, students are asked to attempt to use unfamiliar technologies that interest them. However, they are allowed and encouraged to learn through fake technology prototyping as well. They're required to integrate their group members' technology interests together, as well as their group's other interests and issues. They're also asked to use and create both digital and physical assets, make a systems diagram, and create videos showing usage of their speculative technology systems. Students sometimes become interested in new-to-them tools that their peers from other design backgrounds use routinely, but that are uncommon within their submajor. Some example technologies shown here include photogrammetry, AI-based motion recognition, biosensing digital tattoos, AR for biophilia, 3D and 360-degree computer graphics, and touch and presence sensing. All of the above involves students actually using these technologies, except for the biosensor tattoo, which was fake. While I offer students access to hardware resources, most students prefer to work with technologies that can run on hardware they own or use inexpensive technologies that they can buy. Examples shown here from last year's humanities theme combine 3D printing with NFTs with Greek mythology, augmented reality and historical architecture, networked microcontrollers sensing conspiracy theories, sound visualization of international languages, and immersive exploration of lost religions. For the second project, students are particularly encouraged to monitor their transition from tutorials, that is to say following someone else's clear directions, to their latter stages of making. Students frequently evolve what they want to know. Sometimes it's how things work, or just using the technology as a tool, or figuring out what it can do. They still self-impose pressure to create impressive design solutions instead of merely taking this opportunity to investigate new skills. I emphasize for this project that it's completely acceptable to fail to get a technology working successfully, as long as their investigations and learning are thoroughly documented. For the final project, teams are again encouraged to work on something they want to learn, but they still must collaborate and connect to the annual studio theme. For the first two projects, students scrambled to figure out new processes, ideas, and understand their collaborators. This third project finally provides them with an opportunity to use their new skills and use processes now that they feel more confident about. We frequently discuss, what would you do next if you had more time now that you know what you're doing? And this final project provides that opportunity. I ask them to balance prototyping, functionality, speculative concepts, and research, and each individual and group is encouraged to consider what would be most productive for their design education goals. 2 years ago, some of the final project topics students wanted to prototype involved biophilia, interface design, AR, connected lighting, and VR modeling. Last year saw a brand storytelling with 3D software, a VR historic artifact museum, site-specific cultural music visualization, and simulated sleepwalking surveillance. For the final third of the class, students are usually excited about their new superpowers, and they also have many ideas about what they'd individually like to do. It takes some work on my part to keep them collaborating as a group, the intended purpose of this studio. I field many questions about how little collaboration they're allowed to get away with. Some express the desire for a class that was just like this, only without the group project requirement. Focusing on process sometimes goes out the window at this point due to excitement about specific ideas. Enthusiasm for specific outcomes frequently must be combined with discussion about project scoping. But this shift from over-concern about requirements to overconfidence about capabilities is a great problem for me to have as they try to tackle the complex design problems that they've generated. Throughout the semester, students are given occasional readings on topics related to the new strategies they're learning about. Some examples listed here include topics like generative design, system representations, complex systems, and technology ethics. We do small group exercises where I ask them to consider technologies they're learning about through the lenses of some of these topics. It's not uncommon to hear a few students express some variation of, "I'm not really a technology person," but by going through unfamiliar processes and coming out with positive experiences, students acquire the confidence and basic skills needed to continue learning on their own as their interests and technologies change. They discover that knowing what might be easy or difficult can greatly misalign with their intuitions and will likely require some research. Students are surprised to learn how quickly they can go from discovering a new technology to experimenting with it. Ideally, they change from being not a technology person to having a growth mindset. I think maybe the most important thing has been encouraging students to allow their initial work with new technologies to emerge from capabilities they discover, instead of deciding first what to make and then struggling to meet that goal. This has been very significant for having a positive experience learning about new technologies. It is strikingly counterintuitive for design students who have much more experience targeting well-defined outcome constraints than opportunities for problem discovery. Students, like many of us, can be very concerned about the work they make with unfamiliar tools not looking like it was done by an expert. It's less important to reward students for creating exceptional designs relying on skills they already have than it is to make them comfortable with the risks of creating beginner work. I love Kevin Kelly's point that increasingly we will always, quote, remain in the newbie state because the cycle of obsolescence is accelerating. You won't have time to master anything before it's displaced, close quote. Giving students permission to fail has been another key to encouraging their experimentation. Students express relief at the freedom to attempt things that they can't know whether they will work. I'm constantly surprised by how infrequently the students are limited anymore by a lack of physical technology resources. This is not because of any increase in tech lab access, but rather because of how accessible emerging technologies are becoming. While many expensive technology resources are available in our labs, most students are choosing to work with technologies that run on hardware they own or can afford. Machine learning and AR software runs for free in student laptops, web browsers, and mobile devices. My students are surprised when I show them that their phone or tablet maybe now is a 3D scanner. Easy-to-use microcontrollers and sensors cost only tens of dollars, and advanced 3D computer animation software is free and runs on any operating system. And free tutorials for all these things, of course, are readily available on YouTube. Design strives to positively impact society, and few things are currently having greater social impact than technologies mediated by designers. Smartphones, social networks, artificial intelligence, location tracking, voice recognition, and video conferencing are all being integrated into our daily lives. Enabling designers to better understand and responsibly apply new technologies is a critical need within our discipline. Designers must consider hazards such as racial bias, privacy risks, barriers to accessibility, and mental health concerns. The possibilities and challenges within diverse design topics, such as sustainability, complexity, collaboration, and communication, are being continuously reshaped by accelerating technological change. Developing strategies for adapting to this rapidly shifting landscape is essential. It's easy for my students to drift too far in the direction of excitement about possibilities or to become only focused on negative potential impacts. When the class conversation drifts too far in either simplistic direction, it's useful to nudge things back towards acknowledging the complexity of the situation. And just as students are asked to become comfortable with the unknown and adapt to the unexpected, so too must the instructors. Teaching an emerging technology studio where students follow individual learning interests requires of the instructor many of the same attributes that are being encouraged in the students. Instructors will also need to have a growth mindset, be comfortable with hands-on learning, worry less about imperfect outcomes, and maintain metacognitive awareness. This approach is evolving each semester as students and technologies keep changing. There will always be emerging technologies at all levels of expense and accessibility. Students will always have diverse interests, concerns, and needs. Helping students gain confidence learning to learn about unfamiliar technologies and becoming aware of new capabilities and social impacts will be invaluable as change continues to accelerate. The educational framework I've discussed will hopefully be useful to those considering ways of integrating emerging technologies into collaborative studio courses. I hope this encourages discussion about the challenges mentioned as we work to develop classes that can engage with both technology and the complex societal problems of the future. Thank you, and please feel free to contact me with questions or feedback.